Year 12 mid-course exam. This is paper 1b for the higher level course, and this is question 1. And we begin with a variation on the classic osmolarity question. In this case, we're using cylinders of zucchini tissue, and they're in sucrose solution, and the temperature is stated, and we're looking at percentage changes in the mass of the tissue in these different solutions. So just to check out the graph, we've got percentage changes on the y-axis. Our x-axis, which is labeled here, is actually located here, is sucrose concentration in moles per cubic deciliter, and then the divisions in the scale. We can take a look at that in a moment because one of the questions will be related to that. Note the generally downward trend of the tissue, suggesting that these are increases in mass and these are decreases in mass on this side. From this point onward, they are decreases in mass. So it's always worthwhile analyzing the graphs before you approach the question. It allows you to interpret the question that much more readily. So let's take a look at that first question, which says that they're asking you to estimate the solute concentration of the zucchini cells. So, of course, this is the technique of what is called incipient plasmolysis, properly pronounced plasmolysis. And at that point, what will happen is when we have the cell, we will have a change in mass, even percentage. So there'll be a 0% change in mass because the cell cytoplasm concentration is the same as the external solution, so the net movement of water in both directions is equal. Incipient plasmolysis, this is called. So we're looking for the point at which we have 0% change, which of course is just here on the graph. So now we have to give the value. So let's be careful of our scale. We can see there's 0.2 to 0.4, making this point here, that would be 0.3. And there are 5 divisions, but we're 3 of those along, so that makes this 0.36. So let's put that in 0.36, but we have to remember to give the units, so we can copy them from there, moles per decimeter cubed. There we go. That's the answer to the first question. If the zucchini is allowed to dry in open air, predict how the osmolarity of the zucchini cells would change. All right, so let's think of it like this. Whether we think of the cylinder or whether we think of a zucchini cell, if we're in dry air, there will be a water loss from that, and so there's water loss. And then that has the effect of concentrating the cytoplasm so that the solute concentration will have increased. If we state that in terms of osmolarity, then we would have to say that the osmolarity has increased. Now, some students have used alternative phraseology. Some have said that it's more concentrated, but if you say that, you have to say in where. So in the tissues, in the cell, in the zucchini. So make sure you qualify where is more concentrated. You could say it is more hypertonic, and again you're referring to the tissue itself and not any surrounding fluids. And there is a final one actually, which is that you could say that the water potential, probably in words, has decreased. Any of these alternatives are sufficient to gain the single mark here. These are the last two sections for this question. Explain one reason for calculating the percentage change in mass. Okay, so I think the most obvious one to begin with is that the cylinders that we have are of different size. And so if they're of different size and we calculate the percentage, it gives us a relative comparison. And indeed, we can plot that data. Perhaps you would say that it gives you the opportunity to see an increase or a decrease in the mass of the tissue, the zucchini tissue. That's perhaps an alternative answer. I think this one's weaker than the first one, but different sizes allowing relative comparison, that's going to get you the marks. Showing that there's an increase and a decrease in the mass tissue, again, to allow a relative comparison, will allow you to obtain the 2 marks. And then finally, we're being asked to predict what would happen to a red blood cell placed in distilled water. So I think it's always useful in an exam like this. There's space here that you can use, which is not a problem, and to draw yourself a diagram to allow you to create a kind of context in your mind of the idea that this red blood cell is sitting in distilled water. And so probably you're already thinking that the contents of the cell itself will be more concentrated. You might say they have a greater osmolarity or a lower water potential. Either of those ways of thinking are appropriate. But what we are going to see is that the water will go into the cell. So the water is going to go in, predict what would happen. Water enters cell. And the volume will increase. And potentially the cell will lyse. Note that in this question it's predict, it does not say explain, so therefore you don't have to justify your answer. 5 marks for this question. End of question.